next method of solving systems and our last one. It's called solving by elimination. So we've already solved by graphing and we've solved by substitution. In this video, we'll compare solving systems between different forms, if one's in slope-intercept form versus standard form, and also see the basic examples of solving substitutions with elimination. So remember with graphing is when you just graph it. So here, this equation right here starts at 6 and goes down 2, right 1, and my dots got all blurry. But there's the line y equals negative 2x plus 6. The next one, 3x plus 1, starts here and goes up 3 right 1 and down 3 left 1. They're crossing right here. So I'll graph that line real quick. And that point of intersection is the point 1, 4. So we would say the point 1, 4 is the solution to the system. If you want to solve by substitution, okay, so this right here is me solving by graphing. This is graphing. If you want to use substitution, you take one variable and you plug it in for the other. You can do some solving. So I'll add 2x to both sides. And we get that 5x plus 1 equals 6. Subtract a 1 from both sides, and 5x equals 5. Divide both sides by 5, we know that x equals 1. If x equals 1, plug that in up here. So we had y equals 3x plus 1. But since x equals 1, it's 3 times 1 plus 1. So that's y equals 4. Our solution is the point 1, 4. Okay, so that's graphing and substitution. Those are great if you have a variable solved for already. Or if you're already in slope-intercept form, which is y equals mx plus b. Or if you can easily get a variable isolated without making any fractions or decimals. The other method is called elimination. For many of you, it'll be the one you prefer. We're going to start with very basic scenarios of elimination, where you can just add up two equations. Okay, I'm going to stack the variables on top of each other and add. When I add 3x plus 5x is 8x. 4y minus 4y is just 0y, and 0y would just be 0. So the y's are gone. They've been eliminated. That's why it's called elimination. You eliminate a variable. The y's are gone. I add up 10 plus 70. We get 8x equals 80. That means that x equals 10, because we would divide both sides by 8. Well, if x equals 10, I have to go back and find one of the other variables. So I pick which equation I want. I can go into the top or the bottom, whichever one I prefer. In this case, I'll go into the top because the numbers are smaller. So I had 3x plus 4y equals 10, but I know that x is 10. So that means that 30 plus 4y equals 10, and I'll subtract and solve for y. Subtract the 30 from both sides. 4y equals negative 20. Divide both sides by 4. And y equals negative 5. My solution is the point 4 negative, or 10 negative 5. I'm going to check that. And when I check that, I check it in the other equation. The equation that I didn't use to find variable y. So I'm going to check it in 5x minus 4y equals 70. X is 10, y is negative 5, 50 plus 20, because negative 4 times negative 5 is positive 20, 50 plus 20 is 70. So 70 equals 70, and it checks. I solved the system, got my solution. Okay, so for our first round of problems, we'll only be doing systems where if you add up the variables, if you add up the equations, one of the sets of variables will eliminate immediately. Okay, that'll always be the case when we're doing this first round of problems. So negative 5y plus 6y is positive 1y. I'm just going to write y, because it's positive 1y. Negative 12 plus 14 is just 2. So in this, we just immediately got that y equals 2. Since I know what y is, I plug it back into one of my equations. It doesn't matter which. I'm going to plug it into this equation here because there's fewer negatives. You can pick which one looks easier. I'm picking the one on the bottom right now because there's fewer negatives. Negative 2x plus 6y equals 14. So negative 2x plus 6 times 2 equals 14. So negative 2x plus 12 equals 14. Subtract 12 from both sides. Negative 2x equals 2. Divide both sides by negative 2, and we get that x equals negative 1. My solution is the point negative 1, 2. I'm going to check that again in the other equation. I use an equation that I haven't used yet, really, to find the variable. So I'm going to check in 2x minus 5y equals negative 12. Well, I know that my x value is negative 1. My y value is 2. And my hope is this all becomes negative 12. So negative 2 minus 10 does equal negative 12. So that one checks. Sweet. Okay, last one. Something kind of cool happens here. Okay, look at this equation. I'm going to rewrite it down here for more space. 2x plus 8y equals 12. Negative 2x minus 8y equals 20. When I add up these equations, I'm going to get 0 plus 0 equals 32. Because the x's and the y's canceled. If I have 0 equals 32, that means there's no solutions. I had a non-true statement without a variable, so this cannot be solved. It has no solutions. Okay, so it's a quick little video to get this process started. We'll get more complex and sophisticated in future lessons, but it's a nice place to start. See you next time. We did it. We got through another math video. Thanks for watching. Here I'm going to play with the perspective on these shapes while I talk to you. Please subscribe to the videos, like the videos. Okay, start this thing over. You did it! You got through the video. Thanks for watching. I'm going to play with the perspective of these shapes, which is always pointing towards that center while I talk to you about things. Please subscribe to the video, the channel really. Please like it if you found it helpful. If you want to share it with friends and say, hey, this guy's not the worst, that's an option too. You can always take your video quiz if you're in my class. And comment down below. See you next time.